Welcome back to another video. Now, don't write any of this yet because I want you to do some mental graph for me. Now, close your eyes. Okay, close your eyes. Start with nothing. What I want you to do is you sketch a graph for me or you sketch a curve for me. Are you done? I am sure that most people drew a curve, just like curve up and down, up and down, up and down, and then done. Now, don't open your eyes. Based on your graphing experience, what kind of object breaks your curve into two pieces or multiple pieces? Think. What kind of object, stuff you learned in the past, breaks a graph into two pieces? The answer is vertical asymptote, right? So for example, the graph of 1 over x. So 1 over x, x cannot be equal to 0. Then there is a vertical asymptote when x is equal to 0, right? Now you can open your eyes. So how about this? I have a function on the left, f of x equals to 1 divided by x minus 2. And then I also have the graph for you. So clearly, when you look for the domain, x cannot be equal to 2. So you have to jump over when x is equals to 2. So therefore, when you use interval to describe the domain, I have interval from negative infinity to 2, and then I jump from 2 to positive infinity because there is a vertical asymptote at x equals to 2. And then this is a perfect example to explain non-removable discontinuity. So non-removable, don't worry about why that is not non-removable. I will explain that later. Look at this function, 1 over x minus 2. So there is no way to simplify the numerator and the denominator because there is nothing to be simplified. So based on the denominator, I can tell that x cannot be equal to 2. Therefore, when x is equals to 2, there is a vertical asymptote as you see on the graphs, right? And then how about the other one? Oh, before we move on to the red one, so what can we say about the continuity? So we say that the function, so function f, so let me write this down for you. So f is not continuous at x equals to 2 because x equals to 2 is a vertical asymptote. But if when x is not equal to 2, so you have a negative infinity to 2, and then from 2 to positive infinity. So if you just consider this domain, f is continuous in each of the interval, right? From negative infinity to 2, you can pick anything you want. From 2 or above, you can pick anything you want. So this x equals to 2 is a vertical asymptote. So we say that the function is not continuous at x equals to 2, and then I will explain the non-removable after I explain the next problem. So the next problem is f of x is equals to x squared minus 4 divided by x minus 2. This is a rational function. Most people look at the x squared minus 4 and then they just do a factor and then factor that to x plus 2 and x minus 2, right? And then you can get rid of the x minus 2 right over there. So as a result, the function is equals to x plus 2. So that is a linear function. The y-intercept is 0, 2. The slope is equals to 1. Is a straight line, right? So the domain of the straight line, I gave you the graph as well, is from negative infinity to positive infinity. You pick a random number for x and then you add 2 to it. Of course, you can pick any number you want. Now, let's go back to the function. X squared minus 4 is quadratic because x is raised to the second power. So if you just think about x squared plus 4, you are going to argue with me and say that, all right, we have x squared plus 4. Hey, are you kidding me? X squared, that is supposed to be a parabola, right? So x squared plus 4, whenever you see a square, there is no way to get a straight line. So I am thinking about that your graph is wrong. So is this graph wrong? My answer is this graph is partially right. So let's take a look at the function one more time. Do you see that we have to factor the top? So we have x squared minus 2. So this one, let's do this in another color. So we have x minus 2 and then times x plus 2 and then divided by x minus 2. So if you just look at this without any cancellation, do we agree that x cannot be equal to 2? All right, x cannot be equal to 2 because when x is equals to 2, I have a 2 minus 2 in the denominator. I cannot have 0 in the denominator. So it looks like x equals to 2 is a vertical asymptote. So that's why we say that the graph is wrong. However, the numerator can be factored, and then after the factoring procedure is done, I can do a cancellation. So that means it looks like I can do some algebra to cancel the vertical asymptote. So what is the graph look like after the vertical asymptote is cancelled? The answer is when x is equals to 2, there is an opened circle. So what is the graph look like? So when x is equals to 2, so you have f of x equals to x plus 2, right? This is a linear function. When x is equals to 2, you have a 2 plus 2 equals to 4. It looks like when x is equals to 2, y is equals to 4. This is an open circle. Where is the open circle? When x is equals to 2, y is equals to 4. The open circle is right over there. So that means this graph is correct, but you have to use an open circle at 2, 4. So let me just sketch a new graph for you. So the graph should look like this. You don't need any graphing paper. So when x is equals to 2, y is equals to 4, you have an open circle, and then you sketch the line. So one goes there, and then one goes there. How do you describe the continuity? We can say that f is not continuous at x equals to 2. But x equals to 2 is no longer a vertical asymptote because we just cancel the vertical asymptote. So if you can do some algebra to cancel the vertical asymptote, then the vertical asymptote becomes a removable discontinuity. So the discontinuity is x equals to 2. So x equals to 2 is a discontinuity. I should say is a removable discontinuity. Because we can do algebra to get rid of the x equals to 2. We can do some algebra to get rid of the vertical asymptote. So the vertical asymptote becomes a removable discontinuity. The cancellation part is the time where we remove the discontinuity. How about the previous function? So the previous function is f of x equals to 1 divided by x minus 2, and the x minus 2 cannot be cancelled, so therefore x equals to 2 is a non-removable discontinuity. That's the comparison between removable and non-removable. So simply speaking, non-removable is you cannot get rid of the vertical asymptote. Removable is you can do some algebra to get rid of the vertical asymptote. So after you get rid of the vertical asymptote becomes an open circle. But at that point, x cannot be equal to 2. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe if you're on your way out. I will catch you all in the next one. Signing out for now.